Hi everyone. We must have faced this kind of situation in our daily life. Imagine that you are running in a rainy day at suppose that at 8 km per hour and rain appears to fall vertically on your head. Appears to, okay, mind it. But the moment you start speeding up to 12 km per hour, the rain all of a sudden start falling 30 degree from the vertical. So what has changed here? Has the rain changed its direction or something else is playing behind this phenomena? Friends, as you all know that physics always involve our day-to-day life incidents and try to explain it. Okay, so this particular problem is also hides some of the important concept of physics, and that is nothing but the relative velocity. And let's see whether we can decode this problem, we can decode this phenomena or not. I hope the journey will be interesting and we will try to make it more fun. So let's stay tuned. So let's move with a small problem from book H.C. Verma, and this particular problem is just the kind of phenomena that we have explained just now, that the physics mystery, that why it appears to change the direction of rain whenever you start moving. So the problem states that a man running on a horizontal road at 8 km per hour and finds rain vertically. He increases the speed to 12 km per hour and finds that the drops makes an angle 30 degree to the vertical. We have to find out the speed and direction of rain with respect to road. Friends, as I have already told you in my last session on relative velocity, if you have not watched that video, then I just want you to go to the playlist of relative velocity and watch that. It will have all the concept that is involved in a relative velocity problem. So whenever you are discussing about in motion, you have to consider the frame of reference. Okay, now what is the thing that is under observation here? It is the rain that is under the observation. And what are the two frames from where you are observing the rain? It is ground and the man. So I have created two frame of reference. You can see first is ground and another is man, and I am taking rain as a particle of observation. So you can see all these things are nothing but the position of this particle or position of this rain with respect to individual frame of reference. So this is the position of rain with respect to man, this is the position of man with respect to ground, this is the position of rain with respect to ground. Now from the vector law of addition, we can see all the vectors are in the same direction, we can simply add them. So position of rain with respect to ground can be written as the summation of position of man with respect to ground and position of rain with respect to man. Similarly, if we just differentiate it, we will find the velocity. Now, as I am telling you the velocity, since velocity is a vector quantity, so all the vector quantity involves what? Vector quantity involves the magnitude and direction. So, we have to consider the direction of velocities also while equating these equations. Okay. So let's come to the figure number 1. This figure number 1, we can see I have just made two direction x and y. Let's take all this direction as positive, no problem. Okay, you can take it as negative also, that is your wish. But once you have fixed the direction with a fixed the sign, then you should not change in between. Now you can see that velocity of rain with respect to ground in x direction can be written as velocity of man with respect to ground in x direction plus velocity of rain with respect to man in x direction from this particular equation. Now see, there is, as the rain is falling vertically, okay, rain with respect to man is falling vertically, so it is in y direction. There is no component of rain in the x direction, so I can write velocity of rain with respect to man in x direction is 0. So this gives us an equation that velocity of rain in x direction is nothing but the velocity of man with respect to ground in x direction. So at first case, the velocity of man with respect to ground is 8 km per hour. So we can put the velocity of rain with respect to ground is 8, right? So this gives us one equation. Now let's move to the figure number 2. When I have increased my speed to 12 km per hour, I can see that rain is falling vertically 30 degree to the vertical. So in that direction, this is also 30 degree. Now if this is the velocity of rain to man, then I can just break this rain velocity in two components from this particular right angle triangle. Now this is the base and this is the perpendicular. So the base will be the cos theta. So I have written VRM cos theta is in vertical direction y, and VRM sin theta is nothing but in x direction, because I have already shown you the coordinate similarly. Now equating the equation of x and y similarly as we have done in the first part with figure number 1. So I can just write VRGX is 8, VMG in this case is 12 because I have increased my speed. So VRMX can be written as -4. Okay, so this is clear. Now at the same time you can see that VRMX is nothing but VRM sin 30 degree. So let's consider VRM as V. Suppose let's consider VRM as V. So V sin 30 degree is equal to -4. So velocity of rain respect to man can be magnitude wise is -8. Sorry, with direction is -8. That means whatever we have considered a positive direction, it is opposite to the chosen direction. Okay. Now similarly, VRGY can be written as VMGY plus VRMY, because man is not moving in the y direction. So the component of man is to y, ground in y direction is 0, and VRMY can be written as V cos 30 degree. Now V I have just calculated, so VRGY can be written as -4√3, and VRGX is already given. So if I just draw VRGX in this direction and VRM in y in this direction, and I'm just considering this is the angle of the VR with the horizontal, then I can write that tan alpha equal to nothing but a VRGY by VRGX. So just you put it the value over here, so minus -4√3 by 8. So this is the angle at which rain is falling to ground in the horizontal direction. If I just want to find out the rain falling to the ground in the vertical direction, then suppose this is the angle. Okay, then in this case the tan theta will be what? VRGX by VRGY. Okay, so it will be just reverse 2 by √3. Okay, now in order to find out the absolute magnitude of the VRG, we have to take from this from this right angle triangle. This is the hypotenuse, this is the perpendicular, and this is the base. So VRG can be written as root over VRG x square plus VRG y square. So this is nothing but the 8 square, that is 64, plus this one 64 into 4, 48, so 112. Okay, so this is the way that we have understood that it is actually the relative velocity that is playing a entire game over here. Okay, and friends, with these things I'm just telling you that the concept of, once you have understood the concept of relative velocity and frame of reference, you can solve any degree of difficult problem. No matter from what books the problem is brought to you, you can solve it easily. So just stick to the concept, just clear the concept. Whenever you are stuck with some problem, again come to the playlist, watch the video, so that you will understand that where you are missing out, if at all you are feeling problem. Otherwise, I have tried to make all the things so crystal that it is not going to create any sort of confusion in your mind, and all this problem is just in a piece of a cakewalk for you if they are encountered in examinations. So with this, I am signing off for the day, and friends, thanks for your support so far. I just will be more, I will be just requesting you that if you are liking the content of ours, please subscribe our channel and share to your friends, share to the friends of yours in the classes, so that we can also get motivated with the growing subscription. Thank you and have a great day.